This is a quick video to show you how to find the value of this definite integral. Probably you would want to graph first. If you have a calculator to do the integral, you probably do a graph first. And so you type in the formula and you go to the graph, and it looks like this. And that's not really the most understandable graph, because the standard graphing window on a TI-84 doesn't have the same width of tick marks on the vertical as the horizontal axis. One thing that can help is zoom decimal. Zoom decimal is a really nice way to clean things up pretty. So you can see it's a semicircle, and it looks like that. And so the area is 1/2 pi r squared, because you could do geometry. But on the calculator, the best place to do it is not on the graph screen. There is a way to get a value of the integral here. I would not choose it because it can introduce rounding errors sometimes. If you quit back out to the main screen, it's alpha of f2 will give you a list of some common things, and you can see integral is there. It's number 4, FNINT, which I think is function numerical integral, but I'm not actually sure. So I'll choose number 4, and it brings up a template which looks exactly like what we want. You just type an arrow around to get to the places. So 0, an arrow to the top, and 6 there, and here, and then square root of 6x minus x to the second power, and then arrow out, don't forget the dx, and it will give you an answer. And that, in fact, is the same thing as 1/2 times pi times 3 squared, which is half of that circle. It is possible on the graphing window to get an area to show up here. It's in calc because you're calculating something about the graph, and you can see integrals of choice. You can hit enter. You can also scroll. You can also type, I want to go from 0, enter, to 6, enter, and it will give me an answer. So sometimes the answer you get on this screen is good enough, is correct to enough decimal places, and sometimes it is not. And it's really difficult to know which it's going to be without trying both of them. And why would you do the problem twice when this screen should be reliable, the main screen should be reliable? So you've been warned. You can see the difference here, right? The 14.137, 2 versus 1, those actually are a little bit different. The rounding error will crop up eventually. They're using different little widths of rectangles, and you just can't know ahead of time where it's going to happen. So use the main screen for this. If you happen to be using the black and white version of the calculator, it works the same way. So I've got my graph. The problem with zoom decimal on this one is the relative size of the window. It actually goes off the side, but you can see that better. You can also zoom square, I think. And you get to things the same way. Alpha f2. There's fewer choices, but one of them is the one you want, FNINT for integral, and then 0 and 6, and so on. So it works the same. But while I'm on this, I'll show you one other thing. When I did the graph, I've obviously typed the function in some place. It is in y1. So another choice you have here, when I get to the place where I want to put in, there it is. I want to put in that function, I can call it y1. And alpha of, I think it's f4, yeah, gives me a list of the y variables. I can choose y1 from that list, and then go over here and say x, and it will in fact give me the same thing. So there it is, 1.14.137.16739, exactly matches. So if you already have the function with a name, you can use that name, and it's alpha of f4 that gets you to the list of the y variables. That's it for this video.